Hello and welcome everyone to the ALZET Osmotic Pumps webinar, Tips for Successful Use. My name is Jim Pham and I am the Associate Product Manager for ALZET Osmotic Pumps. Just a few details on this webinar. It's going to be about 45 minutes. A question and answer session will follow. Now, in order for you to better hear me, we're going to leave everyone muted for now, but if you do have questions, then please feel free to ask them via the chat box. The plan is to collect all the questions as they're being asked and then address them in the Q&A at the end of the webinar. And please note that a PDF version of all the slides that I'll be presenting will be made available to all of the participants following this presentation. And finally, I would like to give a special thanks to our ALZET distributors for their help in coordinating this webinar. Here's the webinar agenda. Keep in mind that this webinar is designed for beginner and intermediate users and really anyone who just wants to learn more about the pumps. In the next 45 minutes, we'll go over the background and technology of the pumps, some of the uses and applications, various tips throughout your study, and then we'll end with the Q&A session. So let's get started with the technology behind the pumps and the many benefits that the pump offers. The ALZET Osmotic Pump is an implantable, continuous drug delivery device. The pump can be implanted in animals as small as mice and young rats. However, we have seen them being used in large animals like cattle and horses. Now, these pumps have been around for over 35 years, spanning over 15,000 publications. The pumps are convenient, easy to use. There's a simple design, no programming or software needed. And the pump is fully implantable. Because of that, you can reduce animal stress. Frequent handling of the animal can be stressful. Frequent injections or gavage dosing can be stressful. And the pump is cost effective. You save money on labor costs because you're not in the lab every day dosing the animal. And you save on drug costs because typically less drug is wasted in a pump study. The basic question is, well, why continuous administration? Using ALZET osmotic pumps for continuous infusion will maintain therapeutic dose throughout the course of your experiment, as you can see in that blue line. Unlike injection studies where you get peaks and troughs, at the peak, you're above the therapeutic level and you're overdosing. And this results in unwanted side effects and drug waste. And whereas at the trough, you're underdosing the animal, resulting in the loss of effect. Now, when we say ALZET pump, what exactly are we talking about? Well, the pump is made of two primary components. There is the pump body. This is what holds your drug. And then there's the flow moderator on the right over there. Together, the flow moderator inserted into the pump body make the ALZET pump. Now let's dig deeper and see what's inside each ALZET pump. There are 3 layers to every pump. The outermost layer is a semi-permeable membrane. The middle layer we call the osmotic layer. And the innermost layer is the impermeable drug reservoir. Once the pump is filled and implanted, the pump works by absorbing interstitial fluid from the animal, and this is done via osmosis. Specifically, the osmotic pressure difference between the middle osmotic layer and the tissue environment outside the pump is what causes interstitial fluid from the animal to travel through the semi-permeable membrane. As this body fluid enters and comes into contact with the middle osmotic layer, this middle layer will swell or expand like a sponge. and this expansion from within the pump will squeeze or collapse this inner drug reservoir, forcing your drug out the stainless steel tube, exiting through the tip of the flow moderator. The pump is always but slowly absorbing body fluid, and the drug is always but slowly exiting the pump. And this is how ALZET osmotic pumps continuously administer a drug. A common question we get is, can I partially fill my pump? If I have a 2-week pump but fill it halfway or 50%, does that mean a 1-week infusion? Let's imagine that this pump is 50% full, and that means that 50% of it is air. And remember that the pump is a continuous delivery device. It'll administer everything that's inside of it continuously. Now, in the case of a half-filled pump, it will sometimes administer your test solution and sometimes administer the air. This will not result in a continuous delivery of your drug, and for this reason, the pump cannot be partially filled. This is a chart that summarizes all of our different pump models. On the y-axis, you'll see there are 3 different pump sizes, and within each size is a different pump model with different rates of infusion. The long bars on the x-axis represents the different durations of infusion. Now, for any pump model name, the first 3 digits, that refers to the size of the pump, and then the last 1 or 2 digits, that refers to the duration of infusion. So, for example, focus your attention on the first pump model listed, and that's model 1003D. The 100, that means 100 microliters. 3D means 3 days, and right next to the 1003D is the rate, 1 microliter per hour. In total, you'll see there are 12 different pump models. Now let's go over some pump uses and applications. There are many different uses of the pump. So, for example, you can do a systemic infusion of your drug, like sub-Q, intravenous, and peritoneal. With other ancillary products, like a catheter connected to the pump, you could do targeted infusion. You could do targeted delivery to the nervous system, to the arteries, and to various different organs and tissues. Given the many different uses and applications, the pump could be used in numerous research disciplines like neuroscience, cancer, toxicology, etc. We've developed specialized ALZET compatible catheters for the most popular targeted infusion applications. So, for example, there's a specialized jugular vein catheters for mice and rats. There are specialized intrathecal catheters for mice and rats. In total, we have 10 different specialized catheters made of different materials such as silicone and polyurethane. Features include a Dacron patch or retention beads for anchoring, bevel tips or Teflon coating for easy insertion. Not all features will apply to all catheters, but you could visit our website in our specialized catheter section to learn more. In addition to catheters, we have a collection of neuroscience accessories. We offer brain infusion kits, compatible with mice and rats, and with our kits you can infuse compounds to the brain at depths between 1 to 5 millimeters below the surface of the skull. Now you'll need something to adhere the cannula to the skull, so we recommend using a cyanoacrylate adhesive like Loctite 454, which we also offer. Unlike dental cement, Loctite doesn't need to be mixed, and studies have shown that adhering a cannula with Loctite is much faster than it is with dental cement, meaning less time under anesthesia. We also offer different cannula holders, all compatible with the most common stereotaxic frames, such as those from Stolting and Kopf. In addition to targeted delivery, catheters can be used for other pump applications, such as a time pattern delivery of an agent, like an on or off mode, or delivery of agents incompatible with the pump. I'll go more into incompatible compounds later. Another possible application, catheter application, is delayed drug delivery. Now these are pretty advanced catheter applications, so please feel free to contact us if any of these applications interest you. Another common question we get is, you have 12 different pump models, which pump is best for my experiment? Well, choosing a pump is based on many different factors such as animal size, route of administration, duration of infusion. The general rule is that we suggest first considering or focusing your attention on the smallest pump possible for a given duration. From there, you'll need to determine the concentration of drug required to fill this pump to achieve the desired effect in your study. If this calculated concentration is within the solubility parameters of your drug, then your first choice, the smallest pump, is your best option. If you find that the required concentration is too high and beyond the solubility parameters of your drug, then you'll either have to consider a different, faster infusing pump, or you'll have to find ways to improve the solubility of your drug. And in some instances, you could apply both options simultaneously. Going back to our table of pumps, let's go through an example together on choosing the best pump. So let's say, for example, you wanted to infuse your solution for 14 days continuously. Again, we recommend considering the smallest pump possible for a given duration. In this example, the smallest 14-day pump is model 1002. And again, the 100 or the 100 means 100 microliter volume, the 2 means 2 week. You'll see here that this pump infuses at 0.25 microliters per hour. Once you crunch the numbers, if you find that the required concentration of the pump, assuming 0.25 microliters per hour, is beyond the solubility parameters of your drug, then you'll need to consider a faster infusing 2-week pump. In this case, one example would be model 2002. Again, the 200 means 200 microliter volume, and the last 2 means 2 weeks. Notice that this pump infuses at 0.50 microliters per hour, twice as fast as model 1002. Because this pump infuses twice as fast, the concentration required in the pump will be cut in half. You'll need to ask yourself the same question, whether this new, reduced concentration is within the solubility parameters of your drug. On the ALZET website is a drug concentration calculator that will help you determine the required concentration in a particular pump. And here are 2 different screenshots of the drug concentration calculator using the exact same example that we discussed. On the left is the 1002 example, on the right is the 2002. Keeping the desired dose and animal weight constant, but changing the pump model to one that doubles the flow rate, will reduce the required concentration in half. So you'll see to your left with 1002, the concentration is 20 micrograms per microliter, or 20 mg per mil. And on the right, the 2002 is 10 micrograms per microliter, or 10 mg per mil. Keep in mind that not all pumps can be implanted in all animals. There are different minimum weight requirements for not only the different sized pumps, but also the different sites of implantation. Those sites being subcutaneous and intraperitoneal. So for example, any 100 microliter sized pump can be implanted subcutaneously in mice weighing at least 10 grams. However, if the same 100 microliter sized pump is implanted IP, then the minimum weight requirement is 20 grams. So please keep these minimum weight requirements in mind as you're choosing the best pump for your study. If you didn't know this already, there's an online tool called the Pump Selector on the ALZET website that will help you pick the best pump for your study. This online tool will help you choose the best pump using the same methodology that we just went through. Now let's go over some tips for designing your pump study. Before you do anything, I highly recommend visiting the ALZET website. The website has so many different resources and tools at your disposal. So for example, you can stream surgical videos from the downloads page. The guide to use section has a pump selector that I mentioned, as well as surgical implantation protocols. In the research application section, you'll find references to the most common and popular pump applications. Here's an example of a citation that you might find on our website or something that we might email to you. The citations listed are in the same standardized format that you're used to, but with added notes and comments specific to how pumps are used. So for example, we include the agent infused, vehicle, route, animal info, duration of infusion, etc. Now, not all citations will be as detailed as the one you see in this slide. We'll only include this information if it was contained in the original publication. I'm sure you all know how the methods section to some papers can be a lot more detailed than the methods section of others. With respect to the agent, there are characteristics related to your compound which will help you guarantee success when using ALZET pumps. For example, prior to your study, it's important to know the following. Stability. The compound must be stable at 37 degrees Celsius for the duration of infusion. Now we say 37 degrees because we're assuming mammalian physiological temperatures. This temperature requirement can be different depending on what species you use. Also, the compound must remain in solution for the duration of study. Any precipitation at later time periods can clog or block the exit port of the pump. The pump is compatible with a wide variety of agents. For example, they're compatible with peptides, hormones, nanoparticles, etc. The delivery rate is independent of compounds, molecular weight, physical conformation, chemical properties, or size. For example, if your compound is hundreds of kilodaltons, you can still use ALZET osmotic pumps, and here's why. Remember that the agent doesn't exit the pump through the semi-permeable membrane. The agent exits the pump through the stainless steel flow moderator, exiting the pump through the tip of the flow moderator, the inner diameter of which is pretty large with respect to any size macromolecule. For those working with a new drug or coming from an injection or gavage study, a common question we get is, what dose should I use with the pump? Well, when determining the starting dose, we recommend first reviewing prior research using the pumps. And like I mentioned before, we can help you look for this research by going through our own internal reference database. If prior research doesn't exist, then one option is to perform a dose-ranging study with the pump using low, medium, and high doses. Now, what if you're going from an injection study to an ALZET osmotic pump infusion study? Truthfully, there's no simple way to go from an injection PK data study and translate that to a pump dose, but you can estimate the dose if you know the clearance of the drug. And you can contact us if you have more specific questions to this. We'll be more than happy to help you out with that. The pump can infuse virtually any compound, but one big caveat is that the vehicle must be compatible with the pump. We have an extensive list of vehicles that are known to be compatible with the pump, and I'll show you that later. But if you have a new vehicle not on our list or an unknown vehicle combination, then you can test for compatibility using the ALZET Chemical Compatibility Test Kit. If your vehicle is incompatible with the pump after using this test kit, then you'll want to explore alternate vehicles or attach a catheter to the pump that will act as an external reservoir, similar to the catheter application that I mentioned earlier. Here's a full list of the different ALZET compatible vehicles. For hydrophobic compounds, researchers will sometimes use cyclodextrins. The pump is compatible with DMSO, but only up to 50% DMSO. DMSO concentrations greater than 50% may cause pump malfunction. The pump is also compatible with ethanol, but only up to 15%. For agents poorly soluble in aqueous solutions, researchers have used a combination of known compatible vehicles. One example of this is 50% DMSO, 15% ethanol, and the remaining 35% PEG 300 or 400. For all pump studies, we recommend including a vehicle control group. Doing so will help you control for any drug-related or animal-related issues. If any issues arise in your study, determining the source of those issues will be difficult without a control group. Let's say you have your ALZET pumps in hand, and now that you've formulated your solution, here are some tips for preparing the pump. Inside a box of pumps contains the following: 10 pump bodies, that's what holds your test solution, 10 flow moderators. Once the flow moderator is inserted to the pump body, the flow moderator is where your test solution exits. 1 filling tube, this is a blunt end syringe needle that helps you fill the pump body with your test solution, and 1 set of instruction sheet. Now, it is imperative that you review this instruction sheet because it contains detailed steps on preparing the pump. Also, the instruction sheet contains lot-specific data that may differ from our marketing materials. And here's a good example of what I mean. This is actual lot data from one of our 2002 pumps. Now, in our marketing materials, we say that 2002 is a 200 microliter size pump and infuses at 0.50 microliters per hour. Now, when we manufacture these pumps, we try and get as close to these values as possible, but there will inevitably be some variations. And we do vigorous testing to find out what exactly these variations are. So, for example, for this particular lot of pumps, you'll find that the actual rate of infusion is 0.53 microliters per hour. And the actual mean fill volume is 216 microliters. The actual lot data listed in the instruction sheet is what should be taken into consideration when preparing your study and when formulating your solution. ALZET pumps are always applied sterile via a sterilizing dose of cobalt-60, and you should always use sterile technique when handling the pump. If the compound itself is not sterile, then you can fill the pump using a bacterial filter. If you feel like you've contaminated the pump through the course of handling it, we recommend that you clean the surface of the pump by wiping it with isopropyl alcohol. However, the pump or any of the pump components should not be sterilized via autoclave or gas. When filling the pump, be sure to use sterile technique, and also make sure to use the filling tube provided. Now, in the past, researchers have unknowingly punctured the pump reservoir when filling because they used a long bevel tip needle that they found in the lab instead of using the filling tube that we provide. When filling the pump, if you're experiencing any kind of resistance or back pressure, don't be alarmed, this is normal. Instead of filling the pump upright like you see in the image, try keeping the pump body upright but filling by angling the syringe. When you angle the syringe, what you're doing is letting air from within the pump body escape. Now let's talk about the idea of priming the pump, and I'll use model 2002 as an example. This pump infuses at 0.5 microliters per hour, but when you implant this pump, it won't immediately infuse at that rate. It'll take this specific pump around 4 to 6 hours to go from 0 microliters per hour to the actual rate of 0.5 microliters per hour. And this is where the idea of priming comes in. Rather than letting the pump ramp up to the mean pumping rate in vivo, you can let the pump prime in 37-degree saline for 4 to 6 hours and let the pump ramp up in vitro. Now, there's only 4 reasons why you would want to prime the pump before you implant it. And it's listed there. 1, like I mentioned, if immediate pumping is required. 2, if a catheter is used with the pump. 3, if a viscous solution is being delivered. And 4, if the drug solution may have acute toxic effects. Like I mentioned earlier, you can use a catheter with the pump for targeted delivery of your drug. But the question is, how exactly do you attach a catheter to the pump? Well, how you do this will depend on which pump model you have. For example, for 200 microliter size pumps or 2 ml size pumps, all you need to do is remove the cap from the tip of the flow moderator. Doing so will expose a small piece of the stainless steel flow moderator, enabling you to connect a catheter to it. Now it's a little different with the smaller 100 microliter size pumps. This pump is so small that we couldn't fit a cap at the end of the flow moderator. What you'll have to do is remove the entire white piece at the tip of the flow moderator, and this is what we call the flange. You can either find some sterile pliers to break the flange off, and that's what you see in step 3. Or you can carefully slide the flange down the flow moderator and remove it from the opposite end. When removing the flange correctly, you'll be left with a clean stainless steel tube, and you can see that in image 4. And from there, you can attach your catheter at either end. So now that you have your pumps in hand, now that you fill your pumps with your drug sterilely, I hope, here are some tips when implanting the pump. Even before implanting, you may want to review all the resources available. There are protocols inside the ALZET website, there are videos on the website, and depending on the level of difficulty of the procedure, you might want to review the surgical methods from published papers. In addition to the pump, we also offer wound closure products. There's the 7mm reflex system that we recommend for use in mice, and there's the 9mm autoclip system that we recommend for use in rats. In the download section of our website, you'll find surgical instruction sheets for our most popular applications. These one-page sheets also summarize all the tools that you'll need and all the steps required for implanting ALZET pumps. So I highly recommend reviewing these documents before implanting the pumps, especially if it's your first time. Now that you've implanted the pump in the animal, here are some things to keep in mind during the study. You'll want to ensure proper delivery, and there are a few ways you can do this. If possible, you can measure plasma levels of the drug at various time points to ensure delivery. Now, the simplest way to verify or quantify delivery is to measure residual volume of the drug at the end of your experiment. And the process of doing this is pretty simple. All you have to do is remove the pump from the animal and aspirate as much drug as you can from the pump. By comparing how much drug you inserted into the pump with how much drug you were able to remove from the pump, you can easily verify pump functionality. However, we do not recommend that you remove the pump and weigh the pumps to verify pump functionality. When conducting clinical observations, be on the lookout for things like excess edema, signs of infection, pressure necrosis, slow wound healing, and general malaise. Now you're at the end of the dosing period, and you can either euthanize the animal or you can remove the pump, but you cannot leave the pump in the animal indefinitely, and I'll get to why later. There are many reasons why you would want to remove the pump from the animal. Like I mentioned earlier, one reason is it's always good to verify delivery by measuring residual volume. Another reason to use the residual volume is to verify stability and bioactivity of your drug. If your study requires a long-term delivery, then you'll have to remove the pump in order to implant a brand new one. Please note that the pump must be removed by the explant date, and that date is 1.5 times the duration of the pump. And here's what I mean when I say 1.5 times. Let's say, for example, you have a 14-day pump like model 2002. Then you'll have to remove this pump after 14 times 1.5, or 21 days. With a 28-day pump, you'll have to remove it 42 days. Now keep in mind that this explant date refers to the nominal duration of the pump and not the actual duration. Now, ALZET pumps should appear as they did upon implantation. If the pumps are swollen or cracked, it could mean that the drug precipitated and blocked the pumps, or the pumps were left in vivo for too long. Now, what happens if you leave the pump in the animal for too long? Again, here's the image of the cross-section of a pump, and this is a pump in action. Now, as the middle layer of the pump expands, it squeezes the drug reservoir, and that's what causes your test solution to exit out the tip of the pump. Now, at the end of the experiment, imagine that all of the drug has exited the pump, so there's no more orange. Even though there's no more drug in the pump will still continue to absorb interstitial from the animal. The middle osmotic layer will continue to expand. If the pump is left inside the animal for too long, then the middle osmotic layer can swell and expand to the point where it will crack open the outer semi-permeable membrane. In this event, the osmotic layer can spill into the animal, resulting in numerous adverse effects. For this reason, the pump must be removed from the animal 1.5 times the duration of the pump. And if you're curious, here's what a swollen pump looks like. Notice the crack down the center of the swollen pump body, and also notice the bottom of the flow moderator doesn't sit flush with the top of the swollen pump body. A single ALZET pump can infuse from 1 day to 6 weeks, but researchers can extend the total duration of infusion by manually replacing the pumps. In fact, some research have infused test solutions for over 1 year by manually replacing pumps. Here are the steps for replacing the pump, and they're pretty straightforward. I'll let you review them when you receive the PDF version of this slide deck. In summary, today we went through some basic pump concepts, and that's because this webinar is catered towards beginner and intermediate users. If you need more specific information, say about a certain drug or a research application, then let us know and we can definitely help you out with that. Through phone or email, we offer personalized technical assistance. Like I mentioned earlier, there's a lot of information on the ALZET website, so I highly suggest checking that out. On the website, we have surgical videos, technical tips for more advanced users. Our downloadable application sheets and newsletters are also very useful. And there's a feedback page as well. Give us feedback. We are always open to suggestions. If you have any pricing or ordering questions, please contact your ALZET distributor. And one last time, I wanted to thank our ALZET distributors for helping us coordinate and arrange this webinar. Before we conclude this webinar, I'm going to check our chat log here and see if there are any questions from the audience. And while I do, please feel free to ask any questions, any technical questions that you might have about the pumps. One question we had is, can you please provide the PowerPoint later? Yes, definitely. We'll be sending the PowerPoint, or excuse me, a PDF version of this PowerPoint to everyone who signed up for this webinar. It looks like we don't have any further questions, so I want to thank all of you for coming, signing up for this webinar, taking time out of your busy day to listen to me talk about ALZET osmotic pumps. If you have any questions that you've thought of after this, please let me know. Again, my name is Jim Pham. You'll be hearing from me soon with the PDF version of the slide deck. Thank you again.